Today I will be talking about daily QA and integrated MPC in daily practice, so how we use that in our department. So a small introduction about our department. We're located in Antwerp on 4 different locations, and we have 9 Linux, of which 7 normal TrueBeams and 2 stereotactic machines. We have 2 CTs, 1 afterloader for Brachy, and 1 flash research machine. And to make all this happen, we have 22 physicists, 2 physicists in training, 7 dosimetrists, and 3 secretary who help us in getting everything organized. In 2024, we did over 6,000 treatments, so quite a lot. And to do all this, we use RayStation for planning. We have AREA as our own quality information system for the 7 TrueBeams, and Waycare for the 2 stereotactic machines. And in the near future, all of them will use Waycare. We use CRAD for surface guidance, and then we have SunCHECK patient and SunCHECK machine for our patient and machine QA. So with 9 Linux, we have a lot of tests to do every year. So it's about 665 test executions every year, just a normal test, so even without tests after a machine breaks down or something like that. So therefore we needed automation. And then in the past, the choice for SunCHECK machine was made to have everything in one platform, so everyone can access everything from every location, and also to have the automated analysis of the EPID images, so we got rid of the user dependence. So how does that look? So this is one of our machines and all the tasks. I'm sorry that some of them are in Dutch. Today I will be focusing mainly on the daily task. So in the daily task, we have a daily and a weekly check. They are both done by the RTTs. So we have the MPC that is done every day, and then we use the daily QA for weekly tests. So the MPC, for people who don't know, is an integrated self-check tool for variant machines, which uses the MV imager and does a beam check for every energy. So it checks, you can see it here below, it checks output change, uniformity change, and center shift. And then you do, for one energy, you do a more extensive geometry check, which also checks like MLC and gantry, couch, things like that. Important to know is that it works with a baseline for the output for the uniformity. And then the daily QA, so we do this every week as an independent check. And daily QA uses ion chambers for fatness, symmetry, and energy checks, and diodes for light radiation coincidence. And this, so the daily QA also checks output, symmetry, flatness, energy, field size, and shift, and it also works with a baseline. So in the ideal world, the MPC corresponds with the daily QA, and it would be nice to have the comparison. Before version 5, it was not possible to do this in the SNC software. So we had the MPC in the variant software, and we had the daily QA in the SNC software. So it was just eyeballing and comparing the two. But since version 5, it is possible to automatically import the MPC results in SNC machine. So you run the daily task, and then it automatically imports the last CSV file from the last MPC done. If you want to import other results, you can do that by hand by selecting the right folder. So below here, you can see the results of the MPC, but then shown in SNC. So a little example of what this is useful for. So we had a machine which had a slightly increasing uniformity over time. And we wanted to know, is it a real problem with the machine, or is it maybe an imager problem? Because we see quite often that uniformity on MPC increases, but that it's a problem with the imager and not with the energy. So we would like to know So therefore, we can use the results also of the daily QA. So this graph shows in blue the same data points from MPC as the figure on the slide before showed. And then in orange and in gray, you can see the flatness and the energy of the daily QA. So this figure shows that the energy and the flatness didn't change and that only the uniformity was increasing. So that suggests that it's an imager problem and it's not a real problem with our machine. So we did some additional measurements and they also showed that it was not a machine problem, but that it was an imager problem. So afterwards we took a new baseline, and then here you can see that the results are in agreement again. So there's a little disadvantage. The figure on the right here shows how this looks in the SunCHECK software. So it's not possible to scale the y-axis, which makes it very hard to distinguish between the results. But it is, however, very easy to export it to Excel, but it's a little room for improvement. So for conclusion for this example, so we saw that flatness and energy of the daily QA measurement showed no change, and that the uniformity is likely caused by the MV panel. So we did some other independent measurements and new MPC baselines were taken. So I have another example here. The colors are a bit unlucky, but the light blue show the daily QA results and the dark blue show the MPC results. And you see here the output of a beam. And we saw that it was increasing on MPC, and then the daily QA showed the same trend. So here it was a machine problem. So we did absolute asymmetry, adjusted it, and then you can see here that the results for both daily QA and beam checks were lower again and closer to the baseline. So in conclusion, MPC in SunCHECK software helps us a lot with the comparison. It's easier to see what the problem is and whether it's real. For us, because we have people at 4 locations, it's easy that we have all results in one place and everybody can access it at all times. So that helps us with efficiency.